The ability to create tables from a function or create a table and create the function from it is very, very helpful on the SAT, and I'm going to show you how to do both. So let's start by, if we want to enter in a table, we could do that by hitting the plus button, and then you can throw in your points. Let's say we have the point 2, 6, we have the point 4, 10, and 4, 10 is our y value, and we have 6, 14. So you can see that that's shaping up to be a linear equation. It'll put those points there for us. And if we wanted to find the equation of this line, we could do so using a regression. More on that later. If we want to figure out the points that were on any given function, let's say we have 4x plus 6, we can hit this gear over here and hit this button for the table, and it'll give us a table so we can figure out what the y value is at any given value of x. Now we have -2, -1, 0, 1, and 2. We can edit these x values. So let's say we want to figure out when x was -20. That's this point down here. It's -74. Let's say we wanted when x was 24. That would be 102. So how can we use these on SAT questions? Let's try a couple of examples. So first, we can start by matching functions to tables or graphs. So we have a function over here, and let's say we wanted to match it to one of these graphs. Well, obviously, first we want to eyeball it out, right? We got -4x plus 16 divided by, and we put that in parentheses, so we get the whole thing in the numerator, divided by x plus 2. And we can see from left to right, it starts by going downwards, and then there's an asymptote, and then it goes downwards over here as well. So we realize that it can't be A because that goes upwards, can't be B, that goes upwards as well. So we're between C and D. Now what we can do is analyze some specific points. So what we can do over here is hit this gear and create a table. Now we realize that on the two answer choices, there's a couple of key differences. I'm going to focus on the y-intercept over here because we can see that the y-intercept over here is below 5, and we can see the y-intercept over here is above 5. And really quickly looking at our table, we see 0, 8, and if we ever want to test other points, because that is useful and worthwhile, right? There's going to be a couple of times where you might find some graphs that have similar points. So we see we have 1, 4, and you can see over here, right, okay, this first off too low, and then 1 would be way too close. But over here, yeah, that is about 1, 4, so the answer choice would be D. Now we could also work backwards from the function to figure out what matches what a question is asking us. Over here, scientists are estimating the number of trees in an ancient population, and they estimate it doubles every 664 years. There were n trees in a sample where n is a constant. So we can just assign that a value, which is the estimated number of trees after the earliest known sample. So we could just plug these functions in. So first, let's set n equal to a number. I'm going to use 50. Then we can just type in our expressions. So that's n, parentheses 2, and then we raise that to the, and the first one is going to be 664x. 664x. Now, because these are all similarly structured, we can just copy and paste it to save time typing and just edit the exponents. Okay. So we have 664 over x is the first one. So I'm just going to backspace this x divided by x. Then we have x over 664. So I'm going to do x divided by 664 and clear the 664 out. And then the last one is 664 plus x. Now remember, we want this to double every 664 years. So what we can do is create a table and see, does it double every 664 years? So we can start over here because we're not going backwards in time. Just type in 664, right? And we see that that's undefined. And this is technically not undefined. It's just a very, very massive number that isn't being calculated right now. But one way or another, if it was doubling every 664 years, we would expect to see 100 here. So we know that this isn't the correct answer. So now we can create the table for our next function and just keep checking. So we have 0, and then we'll try 664 over here. So over here, 0 is undefined, so that doesn't even start anywhere. And then let's try this over here. Okay, so we start at 50 as we planned on, and then 664. Oh, that's 100. And let's try one more just to make sure. So 664 and then another 664. So we could do plus 664, or we could have done 664 times 2. And we can say, hey, that does actually double every 664 years. So our answer is going to be n times 2 raised to the x over 664, which in this case is answer choice C.